So does everybody have a piece of paper like this that wants one? So I want you to take your piece of paper. First thing I want you to do is fold the top down like an inch, inch and a half. 2 inches is probably too big, but something like that. Okay? While it's still folded down, I want you to take your pencil and run your pencil along the fold. Now look at my nice, beautiful straight line. Everybody see that? Okay. Then I want you to take this side right here and I want you to fold it over, but not all the way over. See how far I'm folding it over only? Yes? And I'm going to run my pencil along the fold, but this time I'm only starting at the original line that I drew from the first fold. Okay? So that when I unfold it, it looks like this. Everybody okay? Help the people around you. Assist each other. Act like your friends. I'm sorry? I folded it about this much. I folded it like right there. I'm not worried about like measuring and getting exactness. Otherwise I would have told you measurements with a ruler or something. Just get about that much. We good? Alright, so let's fill in our paper. Okay? Along the top, right up here, we're going to write this. Real numbers. So this whole paper today is going to be talking only about real numbers. Okay? And earlier they said, well, if there's real numbers, are there fake numbers? And I said, yes, but they're called imaginary numbers. But we're not going to talk about that today. I want to leave that for you to look forward to. What's a symbol for real numbers? You know, like all real numbers? Remember? Yeah. Like that, right? That's the symbol we use for real numbers. Now, I'm going to zoom in on just this big part right here so you can see it a little bit better. Just the big section. Everybody okay with that? Yes. Okay. Now, in the middle of the big section, there's a smaller set of numbers called natural numbers. Sometimes they're called counting numbers because it's how you learned how to count. How'd you learn how to count? 1, 2, 3. So 1, 2, 3, ... right? Continues on. What do you think the symbol is for natural numbers? So it's an N for sure. But like, you know how we have like this fancy R right here? It's kind of like a fancy N. Straight down, diagonal, another diagonal, and then a straight down. Does that make sense? Okay. Including all of the natural numbers, there's also whole numbers. What is a whole number that's not a natural number? Good guess, but not quite time for that. We'll get there in a second. Yeah. And that's in fact the only whole number that's not a natural number. Okay? So is 2 a natural number? Is 2 a whole number? Yes. Because see how it's inside of this circle? Is 0 a whole number? Is 0 a natural number? No, because it's not inside that circle. Does that make sense? What is the symbol for whole numbers? Any guesses? Yeah, fancy W. So including all the natural numbers and all the whole numbers, we have another set of numbers that's called integers. What kinds of numbers are integers that are not whole numbers or natural numbers? What? Absolutely. So like -3, -2, -1, -5, -7, all of those numbers, right? Any idea what the symbol is for integers? So that would be logical, right? A fancy I would be logical, but remember in math we're not always logical, right? But to be fair, if I tried to draw a fancy I, wouldn't that just look like a rectangle? That would get confusing. So instead we use a fancy Z. Because you know, integers... No, not really. I don't know why it's a Z. They said it was, and so I just go with it. Okay? Now, all the rest of the numbers that are in this section, still just in this rectangle right here, all of the rest of these that are left are called rational numbers. So what is a rational number that's not an integer or whole number or a natural number? Now, 4.8. So what kinds of numbers are included that weren't included before? Decimals and fractions. So like 1/2, like 2/3, like -5.6. Everybody understand that? Okay. What's the symbol for rational? Fancy R would make sense, but that's already real, right? So it's a fancy Q, because I guess that's next to R, you know, near it. Guys, what is a rational number? What does that actually mean? What is a ratio? A fraction, right? So basically, a rational number is the number that can be written as a fraction. Yes? So then what do you think this box is over here? If this is rational, irrational. Can you give me any examples of an irrational number? So that would be rational. That's okay. It's a good guess. If a rational number is a number that can be written as a fraction, an irrational number is a number that can't be written as a fraction. For example, pi. Exactly. Do you know any more? So think about that. Think about this, right? Isn't this 0.666666666, and then at some point we round to 7 because we don't want to write sixes anymore? Isn't this a repeating decimal? But could it be written as a fraction? Yes, so it's over here in rational. Okay, so that's a good thought. There's a whole lot more, just so you know. There's a ton. Like there's a whole branch of mathematics that just studies irrational numbers. Okay, what about this one? Or this one? Or this is one of my favorite right here. I know for your whole life you've been told that that's a letter. Well, that's because it is. But in math, we use this letter to represent a very, very specific number that happens so many times in like natural things in nature that I can't even list them all. Like when we get there, I'll show you all the examples I know of, but there's also, well, I can't even show you all the examples I know of because that would take forever. I'll show you a bunch of examples, okay? But it's not just a variable. You know, like we use X and Y for variables. This stands for a very, very specific number, okay? And while it can't be written as a fraction, it can be approximated, and that approximation is even stored in your calculator. It's used so often. Okay? So, do you have any questions about this, our fun page that we made today? We're good? Okay. We're going to put it aside, but don't put it away, because we're going to need to refer to it as we take the rest of our notes. Yes, sir? Oh, that's a good question. And if there is, I don't know it or care about it. Just being honest. Okay? I will look that up for you so I can tell you. So it looks like there's one, but at least on this site, that they don't even agree on it. Let's go here. Oh, now the internet's not going to work. Awesome. Very good question. Thanks for making me look it up. Okay? All right. Now we're going to take some notes on notebook paper. What do you think should be at the top of every single thing of notes that we ever take? The date. Okay? Now, to avoid confusion, we are not on the same piece of paper that we wrote our lesson plans on. Okay? It's a whole brand new piece of paper. I don't care if you write August 31. I don't care if you write August 31, 2021. I don't care if you write 8/31/21. However you want to write the date, get it up there. What is the topic for our notes today? Domain. So let's get the topic there as well. Okay? When we did our worksheet on parent functions a couple days ago, we talked about both of these kind of domains already, right? Inequality and interval, inequality interval, inequality interval, inequality interval. You remember doing those? Okay. So, for example, if I tell you that the inequality domain looks like x is greater than or equal to 5. X is greater than or equal to 5. What does that look like in interval notation? Well, if it starts at 5 and goes where? All the way, right? If it starts at 5 and goes all the way, now I just have to remember what symbols go around this, don't I? What always goes with an infinity? Parentheses. Is this 5 included as part of my domain? Is it greater than or equal? If it's or equal, it's a bracket. Now our textbook also wants you to know one other kind of domain. But you already know how to do it. Believe it or not, you already know how to do it. Can I show you what it looks like and prove that you already know how to do it? Even though you really don't, because I haven't taught you yet. Okay, here's what it looks like. Pretty braces. X such that x is greater than or equal to 5. Guys, if I took off the braces, what does it look like? Inequality. It's almost exactly the same as inequality, right? So I just have to have these pretty braces around the outside because this is set builder notation. So I have the braces. And then I'm telling my reader we are talking about x. We are defining our variable. If we were using y, it would go here. If we were using a, it would go here. Whatever we need to use, we're saying we're talking about x. And then I have a vertical line here that means such that, and then I have the same thing as that I would have for inequality. X is greater than or equal to 5. Okay? What would that look like on the number line? Well, there's 5. It would be a colored in circle with an arrow going which direction? To the right, because that's where greater than is, right? Now, remember how I told you sometimes I know where we're going, so I have to add a couple things in to help you out? Okay? Now, our textbook uses this, but the college algebra stuff that I teach from uses something different, so I want you to have seen that as well. There's the 5. What did we use on our interval notation? On the 5? A bracket. So I could put a bracket here with an arrow going this way. That's also acceptable. Does that make sense? Okay. So what if I started with interval? What if I said negative infinity to 4? If I started with interval, can you go backwards to inequality? What would it look like? X is? What direction is it going? To the left, right? It goes to negative infinity, less than or equal to? No, because of this parenthesis right here. 4 is not included, so just less than 4. What does it look like then in set builder notation? Brace x such that x is less than 4. What's the graph look like? There's 4. Would it be? Open or closed? Open, because 4 is not included. And then I have an arrow to the left. Right? And what's the other way that it could look? Absolutely. Here's the 4, and then it has a parenthesis on the 4 with an arrow to the left. Sorry, that's kind of a wonky looking parenthesis. Everybody okay so far? So what if the inequality notation looked like this? Negative 3 is less than x is less than or equal to 5. What do you want to do first? Interval, set builder, or the graph? First of all, does it matter? No, it does not. Okay, so you said interval, so where is it going to go? From negative 3 to 5. What goes around the negative 3 and what goes around the 5? Parenthesis around the negative 3. Bracket around the 5. And how do you know by looking over here? If it's just less than or just greater than, it's a parenthesis. If it's just less than or equal to or greater than or equal to, that's the bracket. Okay? Set builder notation. Get your braces in your x such that, then you just write the inequality, right? So what does the graph look like? Absolutely. Yeah, I want negative 3 and 5 on the graph. So what goes on the negative 3? Why do you say that? Because it's a parenthesis here and it's only less than, right? What goes on the 5? Closed circle, because it's got a bracket or the equal to, right? Now I know I have to shade because that's the whole purpose of making graphs at this point, but where do I shade? Well, where's the x? It's less than or equal to 5 and it's greater than negative 3, right? Guys, that confuses people sometimes because you've been taught your whole life that's a less than sign, right? But if we're reading from the x, it says x is greater than negative 3. Does that make sense to you? Because I have to read this way, okay? So I'm going to end up shading in between them, right? What does it look like if I'm doing it the other way? A parenthesis on the negative 3. Very good. And a bracket on the 5. And shading in between. Okay? So now I have to throw a wrench in things. Because you seem like you've got this pretty good, right? So, because I'm your math teacher, I have to make it harder. That's a rule, right? Okay. What if I tell you some words? List all integers between negative 3 and 5, and I want the answer in set builder notation. Well, guys, isn't this kind of like a graph of everything in between negative 3 and 5? Except this would have to have a parenthesis because 5 is not in between negative 3 and 5. It is, right? But the problem is this word right here. Integers are these, not these. So if I'm going to list it in set builder notation, I have to start with this, right? How am I going to show that I'm talking about an integer? The symbol. I have to use some other fancy symbols too. I have to say x is an element of the integers that are between 3 and 5. Does that make sense to you? It looks like I'm writing in Elvish or something, right? Okay, let me start right here. You got the x is a member of, right? Or x such that, because that's the same as all this other stuff that I showed you up here. I said x is an element of the integers. That means the numbers that I'm choosing are only integers. And x is between negative 3 and 5. So I don't have or equal to on either one of these, right? Because I just want numbers that are between negative 3 and 5. It doesn't say between and including negative 3 and 5. It's just between. Yes? What would that graph look like? What would it look like? I drew a number line for you. What goes there? Any guesses? So we could put that, but it's not necessary. But wouldn't I have a closed circle here? And a closed circle here? And here? And here? And here? And here? And here? Because it's not everything in between, is it? It's only the integers. And because I want everything between negative 3 and 5, I'm not including negative 3 and 5. Does that make sense? What if these words showed up then? List all elements of this set in braces. What are braces again? And don't say those things on your teeth. Don't. These, right? These are braces. Okay? What are all the elements in the set? Didn't I just put dots on all of them? So -2, -1, 0, 1, 2, 3, and 4. Questions?